Today we're going to be looking at two problems from chapter 7 and chapter 8. I chose these two problems because they were tricky at first because they look challenging, but they are actually easier than they look. So we have if sine A equals 12 over B in quadrant 2 and sine B equals 4 over 5 in quadrant 1, find cosine A plus B. So looking at this alone, we can tell that this is a sum and difference problem. And we have a formula for this, and that's going to be right here. I wrote it to save some time, and that would be cosine A plus B equals cosine A times cosine B minus sine A times sine B. So because we already have sine A and sine B given here, we're going to be finding cosine A and cosine B to complete this. To do that, we're going to look at this first, and then we'll look at this one. So we can look at it on a graph. It's in quadrant 2, so we'll draw it in quadrant 2. And then we have opposite, hypotenuse, adjacent. And so katoa, so is opposite over hypotenuse, so 12, 13, and we don't know what A is, but we're going to use the Pythagorean theorem to find that. 12 squared plus B squared is equal to 13 squared. 12 squared is 144 plus B squared equals 169. Subtract 144 on both sides. B squared equals 25. Square root both sides. B equals 25. Plus or minus 25, but we know from this that it is going to be negative, plus or minus 5 is what I meant, and we know it is going to be negative 5 because it's in the second quadrant. Over here is all negative, so there we go. And now from here we can look and find for cosine A. So cosine A is opposite over hypotenuse, adjacent over hypotenuse. So it's going to be negative 5 over 13. Now we found the first one. That's great. We're going to find the second one using this one. Same thing, we're going to look at a graph. It's in the first quadrant, so we'll draw that there. And sine, opposite over hypotenuse, adjacent. So katoa 4, 5. We don't know what A is. We're gonna find that with the Pythagorean theorem. Same thing. 16 for 4 squared. And 5 squared we know is 25. Subtract 16 on both sides. B squared equals 9. Square root both sides. B equals plus or minus 3. We know that it is positive 3 because it's in the first quadrant. All the values on this side of the x is positive, so 3 there. And we are looking for cosine B, so we have 3 over 5. Great, now we have the both values that we were looking for to complete this formula, so we can put this in now here. Cosine A plus B Okay, so I've written this out now. We have negative 5 over 13 times 3 over 5, subtracting by 12 over 13 times 4 over 5. And now we can just put that in our calculator. And if we put this in our calculator, we get negative 0.96923 and more. If we turn that into a fraction, that's negative 63 over 65. And that is our final answer. Pretty easy, looks a little bit scary, but it's all right. Now, we have rewrite equation y equals 3 in polar form. And we know that there is a formula, there are 4 formulas in the polar form, but there's one we're going to be using here. It's y equals r sine theta. And we know that y here is 3. We can just plug this into y. 3 equals r sine theta divided by sine on both sides. This is technically 3 over 1 times 1 over sine theta. And that equals 3 cosecant theta equals r, which is our final answer. So both of these questions aren't as hard as they look, which tricked me at first, but now I understand them.